welcome back to another video of daily LeetCode challenge streak series, and in today's video we have a new LeetCode medium question that says house robber.
Now let's see what the question says. You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is the adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Now, what do we have here? We have nums and we have an array given, and we are supposed to return the maximum number of adjacent elements sum. Let's take an example to understand this question really well. 1, 2, 3 and 1. Now, starting from this first element, we are supposed to traverse through the array and get the maximum sum but of the adjacent elements. Now, we have two options. We either start from 1 and go till the last element. Okay. Now we have 1, 2, 3 and 1 again. So we either pick this element and this element, or we pick this element and this element, because we can only choose the non-adjacent elements. Okay. We can only pick the non-adjacent elements. Okay. Now what is the sum here? It is 1 plus 3, which is 4. It is 2 plus 1, which is 3. What is the maximum of these two? It is 4. So you will return 4 in the answer. Now let's consider a different example. 2, 7, 9, 3 and 1. Now what is one set of non-adjacent elements we can take? It's either 2, 9 and 1. 2 plus 9 plus 1, which is equals to 12. Now what is the other set that we can take? It is 7 and 3, which is 7 plus 3, that is equals to 10. So since 12 is the maximum, our output is 12. Now, what can we do for this? When we are trying to solve recursion problems, I told you that any such recursion problems where we are trying to return maximum or minimum or number of ways, we have to convert that function into an index problem. Okay, so anytime you are trying to write a function, we are supposed to convert that into an index. Now, what does this index here represent? Now, we should try to represent this index in such a way that this function will help us in returning the maximum sum till this particular element index from 0. So, if you are trying to solve f of 2, then f of 2 will return the maximum sum of non-adjacent elements from the index 0 to 2. If it's f of 10, then this will return the maximum sum of non-adjacent elements from 0 to 10. Now, next, how do we solve this? Now, if you carefully observe, while picking these problems, we either, if we pick the first one, then we will go to the two indices which is next to the one that is picked. So, if you are taking element 0, we will go to element 2. And if we take element 2 again, we will go to element 4, not 1 and not 3. So the other case that we can consider is, we can start from 1, then go to the index 3, and then go to index 5 and skip 2 and 4. So, and then we will compare the maximum sum of these elements and return it accordingly. Now, what are we doing here? We have two cases. We either pick the element or we do not pick the element. Okay. So, what are we doing if we pick the element? We are assuming that we start from this element and we go behind and we travel behind and not from 0. So you can either go from 0 to 4 or come back from 4 to 0 by choosing alternate elements. So if you are picking the element 4, you are taking that index. Okay, you are considering the index of that array and you are shifting two elements behind it. Okay, so now if you consider the example 2, 7, 9, 3, 1, you will pick the element 1 and you will go to 9. So you are moving two indices before. So you will call the function ind minus 2, int minus 2. Now, what if you are not picking it? Now, if you are at index 1 and you don't want to pick it. If you don't want to pick it, what will you do? What will you do? You will simply go to the next element. You will simply go to the next element. So, you are not taking any element and you are going to the previous element. You are going to the previous element. Now, let's talk about the base cases. Base cases, we have two types of base cases. One, we reach the destination. Two, out of bound cases. Now, what is the destination here? From 1, we go to 3, from 1, we go to 9 and then we go to 2. Now, that means that if index equals to 0, if we reach the index 0, it means that we didn't go to the 7, okay? We were at 9, which is why we could come to the 0th index. So if we are directly at the 0th index, so we will definitely consider it. We will definitely pick it to get the maximum sum. So we will just return the value that is at the 0th index. Okay, we will return the element that is at 0th index. Now what is one other base case that you can think of? Now it is that if you are at index 1, okay, let me write it here again, 2, 7, 9, 3, 1. Now suppose you came to the index, you came to this place, okay, you are at index 1 and you picked this element. Now what will you do? Usually if you pick the element, you will take the function you will take that element and call the function int minus 2, meaning you will move 2 indices behind. So what will happen? 1 minus 2, which is equals to minus 1. If 1 minus 2 is equals to minus 1, what does it mean? Negative index. Is negative index possible? No, it is not possible. It will become an out of bound case. So, we will write a case such that whenever index value goes below 0, we will be returning 0 because there is nothing to return and we will be returning 0. And in the end, what are we returning? We are always returning the max of both these cases. Okay, now we'll be returning this. Now, talking about the time complexity. Since for each and every element, we are checking the pick and non-pick condition. Okay, so for every element, we are taking pick and non-pick. So for n elements, for all the n elements, you will check 2 cases. Okay, so what will the time complexity become? It will become 2 power n. For this, the stack space required and the recursion time to compute all of this will be so much. Why? Now let's consider an example. Consider the function f of 3. For this, you either pick it or you don't pick it. If you pick it, what will happen? You will go to f of 1. If you don't pick it, you will go to f of 2. Now again for f of 1, if you pick it, you go to f of minus 1. If you don't pick it, you go to f of 0. Likewise for f of 2, if you pick it, then you go to f of 0. If you don't pick it, then you go to f of 1. Now if you see, if for f of 1, if you are at f of 1, now you are calculating the value of f of 1. Likewise, when you come down here again for f of 1, you again have to compute its value. So instead, what do we use? We use dynamic programming array. We use DP array. What will happen in the DP array? We will store the values of these respective functions so that we don't have to call these values again. So if you are at f of 1, we will compute it first and we come back to this f of 1. We will directly use the value from this DP of 1 array. Now, we will just have to simplify this a little bit to convert this into DP array. So now what do we do for that? We initialize a DP array of size n with all minus 1 in it. Now, as we discussed in the previous videos, when we initialize these minus 1 and whenever we compute the DP values, we will be storing those values in place of minus 1. We will remove the minus 1 and see. And before removing that, we will check if there is a value other than minus 1 in it. If the value of DP of index is not equal to minus 1, okay, then we will directly return the DP of index value. It means that the value is already solved. Otherwise, we will start computing by the pick and non-pick method, and in the end, whatever max we have here, the DP of end here would be pick max of the DP of end here would be max of pick, not pick. Okay, and likewise here the dp of 0 would be stored as ARR of 0 value. Okay, since we are directly returning the ARR of 0 value here. Okay, and if the index falls below 0, then we will directly return 0 here. Now, what will be the time complexity of this thing? Since we are iterating over all the elements to compute the dp of index value, the time complexity would be O of n. Now, what will be the space complexity? Additional to this recursion space tree, additional to this thing, since we are storing a dp array of size n here, of size n, the space complexity would be O of n plus O of n, which is equal to O of n. Now, how can we make this space better? Now, if you properly look at this thing, if you see the f of int minus 2 is nothing but dp of int minus 2 value, and here, so let me write this whole thing again. For this f of index value here, we for dp of 0 will be ARR of 0. Okay, and if index is less than 0, then we'll be returning 0. Now, what are we checking next? If dp of int is not equal to minus 1, then we'll be returning dp of int, meaning it is already computed. Okay, otherwise what are we doing now? For I is equal to 1 to n. Okay, starting from the index 1 to index n. Why index 1? Because the dp of 0 is already computed, it is ARR of 0. So to find the values from dp of 1 to dp of n, we have pick and not pick. Okay, for pick, we will be taking that array element in ARR of int, and we will be calling the function. What will be, instead of calling the function, we will just write dp of int minus 2. We are going 2 indices behind. For not pick, we won't take LE element and move to the previous element. We will move to the, and in the end, the dp of int is equal to nothing but max of pick comma not pick. Correct? Now, if you properly check here, in every iteration, we are only storing our dp of int minus 2 value and dp of int minus 1 value. When we have 3 elements, okay, when we have say 5 elements, assuming 1, 2, 3, 4 and 5. Now let's have another variable set to 0, which is previous 2. Okay, and this is previous 1. Okay, this will be previous of 1. Now, currently this will be previous and its next element will be current. Now, what is happening when you apply the for loop from the index 1 to n? Why not from index 0? Because you predominantly set the index value to be the ARR of 0 value. Index of 0 value in the DP array, DP of 0 would be ARR of 0 value. So, to compute the other values, you will start from 1 and go until n. Now, what do? Now, if you are picking the element in the previous methods, since you are already taking whatever element is in the index, so pick, you already added to ARR of index. Okay, you will add it to ARR of index if you are picking it. So, if you are at say 2, if you are at 2, you will, if you are picking it, then you add it to your pick. Next, what are you checking? Now, if you also want to add the previous value, okay, for example, you are 1, 2, 3, 4, 5. If you are at 4 and you are picking it, so you add pick is equal to 4. Now, since you are at 4 and you should also add the value of its non-adjacent previous, which is 2, you should go back and add its previous value, which is previous of 2. So, we will keep a counter. This will be previous 1 and this will be previous 2. So, you add this previous 2 value to this pick. Why? Because you need maximum sum in the end. For that, your value should be updated. So, which is why for this, if the number of elements, okay, if the index value, if it is greater than 1, then you will be adding a previous value. Why should it be greater than 1? If you are here, there is no previous of previous, because the elements here only start from 0. So, if you are at 1, the previous will be this, and the previous of 2, it doesn't exist. So, for you to add the previous of 2, if you are at 1, it means that this whole array is only starting from here. For you to go to the non-adjacent, this will only be the first element that you check. So it will be 1, 3 and 5. But if you are at 2, it will start from 0 because 0 is some previous to value that you have already initialized. So if I is greater than 1, you get to add the previous two values since you are already initializing it here. So you always add, okay, if I is greater than 1, you always add pick plus is equal to previous of 2. You are adding that value. So if you are at 4, then you will be adding the value 2. Okay, now what happens next? Otherwise, what is the otherwise case if you are not picking the element you are at? So if you are at 2, if you are at 2 currently and you are not picking this element, so you don't add anything to it, but it means that if you are not picking this thing, it means that you already picked the element before it. You don't pick adjacent elements. So if you are at 2 and you didn't pick it, it means that you picked 1, which is why you didn't pick its adjacent element. So you will be adding previous of 1 to that element. Okay, it means that if you are at 2, you picked it, so you will be adding that to the maximum sum. In the end, what are you doing? So the current would be maximum of pick comma not pick. Okay, pick comma not pick. Now you have to update the counters, for you to, if it is 1, 2, 3, 4, 5, 6, if you are at 4, you will just add 2, that is enough. But if you are at 6, you just don't add 4, you should add 2 also. For you to have 4 plus 2 is equal to 6, you should have the values stored somewhere. Which is why the previous of 2 moves to previous. So if there are 3 elements like this, 4 elements, now this was previous to, this was previous, and this is current. Now in the next iteration, what happens, whether or not you pick it, this current moves here. So this is current, now this is previous, and this is previous of 2. Now previous of 2 became, now here previous of 2 became current, previous of previous. So it is previous. Now what did the previous here become? It was the current. So previous is equal to current. Now what are you returning in the end? If the current goes outside, whatever element is in the previous, you will return the maximum sum till there. Since you are updating the current value in the previous already, you can directly return previous. Okay, you will directly return previous. Now what is the time complexity? Since you are iterating over n elements to get the maximum sum, it will be O of n. Now what will be the space complexity? You are only storing previous 2, previous 1 and current values, which is like the fixed variable elements. It's fixed constant elements. You are not storing the elements in some arrays of n size. There are just 3 elements of fixed space. So it is O of 1.
Okay, now let's quickly code this up. We have a function drop given in which we are sending an input array nums. Now let's first note down the length of the nums array. Now what are we doing next? We are setting 2 variables, previous 1 and previous 2. Now what are we setting this previous one array to? Since we'll be directly returning ARR of 0 value, nums of 0 value that will be stored in previous and 1, and since previous 2 is defaultly set to 0 ones, and as we go by the array we will increase its value accordingly. Now we are taking a for loop for I in range 1 to n. Now why 1 to n? Because we have the zeros value, as in the num of zeros value already defined. So we'll start from 1. What is our first condition? If we pick, we will directly assign this current index value to pick. Now what are we also checking? If the index value, okay, now if the index value is greater than 1, then if we have more than one element, in the case if we take the example 1, 2, 3 and 4, if we have more elements, if we are at 3 and we have more than one element, then we will also add this previous value. So pick plus is equals to previous of 2. Correct? Now what are we doing? What is the next condition? It is not pick. So if you're not going to pick this 3 value, then we are not going to add anything to it. But if we did not pick 3, it means that we picked the previous value 2. So we will add it to our sum. Okay, now next, what are we doing? We are updating our current value to the maximum of pick comma not pick. Okay, then what are we doing? If we have our 0 which is previous of 2, okay, one sec. Now if this is previous of 2 and this is previous 1 and next is current, in the next iteration this becomes previous 2, this becomes previous 1, and the next element becomes the current. So what will happen here? What will happen? The previous of 2 becomes previous of 1 and previous of 1 becomes current. Okay, in the end what are we returning? We are returning the current value that is being held by previous 1. Now let me just remove this and quickly run the code. It's accepted. Let me just quickly submit it. This works. Now let me just write down the time complexity here. The time complexity is O of n, since we are iterating over n elements here, and the space complexity is big O of 1, since we are not using additional space except for these 3 fixed space variables. Thank you guys.